share my screen and let me know once my screen is visible to you guys. Is my screen visible? Guys, is my screen visible to you all?
Yes, sir.
Okay. So today we'll be learning about DNS, Tailnet, and SSH. We have already covered application layer and DHCP in the last lecture. Okay. So let's start with DNS. So what is DNS? So DNS stands for Domain Name System, and it's like the internet's phone book. Okay. It helps you to find website by translating easy to remember names into the numerical IP addresses that computer used to locate each other on the internet. Without DNS, you would have to remember long string of numbers to visit your favorite websites. So DNS, what it does is it converts the IP addresses related to the website into this form so that it is easy to remember. So what does this line mean? It's like a phone book. So inside phone book, when you search for someone, you search is it's your search. The search is by name, right? Not by number because it is sorted in alphabetical way. So it's same like that. This is internet's phone book where all the IP addresses are stored. Domain name system is a host name used for IP addresses translation services. DNS is distributed database implemented in hierarchy of name servers. It is an application layer protocol for message exchange between clients and servers. It is required for functioning of the internet. Okay. So if I open my command prompt and if I type ns lookup www dot let's say crickinfo.com. So it is giving me this. There are a lot of information, but the information concerning me is this one, the address. So if I copy this address and if I type it here, so it takes me to Crickinfo web page. So what DNS is doing is DNS is converting this into this. Okay, guys, any doubt about this slide?
No, sir.
Okay. So what is the need of DNS? So every host is identified by IP address, but remembering number is very difficult for people also. The IP addresses are not static. Therefore, a mapping is required to change the domain name of the IP addresses. So DNS is used to convert the domain name of the website to a numerical IP address. Okay. The names it converts into IP addresses. DNS translate domain names to IP addresses, making it essential part of the internet. So suppose I'm working for a company and I have a name and I have an ID. So everybody knows me by my name, not by my employee ID, right? So that is why DNS is important because it is easy to remember www.crickinfo.com rather than the IP address. Okay, and also the IP address related to Crickinfo is not static; it's dynamic. It can change depending upon where the website is hosted. Okay. Now, types of domains. So there are mainly three types of domains available. First one is generic domain. Generic domain is what we see in the end of any uh, link like .com, .edu, .mil. .com is commercial, .edu is educational, .mil is military, or .org is non-profit organization. .NET is similar to commercial, and all these are generic. These are all called generic domains. And then we see something like .in for India, .us, .uk, and then there is inverse. Inverse domain is opposite of what DNS is doing. So if you want to know what is the domain name of the website, IP to domain name mapping. So DNS can provide both the mappings. For example, an inverse domain might show IP addresses 192.168.01 corresponds to the domain name of router.example.com. So this is how it is configured. There is a root domain, and then there are generic domains, country domains, and then are inverse domains. So any doubt on these domains?
No, sir.
Okay. So this is a hierarchical method where the root server is connected to the top level domain server, and then there is authoritative server. So we'll discuss in details about, but you just need to remember this, how this hierarchy is based on. The first is root server, then is top level domain server, and the last one is authoritative servers. So name to address resolution. So how it happens? So the host requests the DNS name server to resolve the domain name, and the name server returns the IP address corresponds to the domain name to the host, so that the host can further connect to the IP addresses. So this is a host, and if I need to connect to any website like csc.dtu.in, then what I need to do? I just need to type the address, and this name server, what it does is it resolves me. It gets the IP address, and so that I am able to get to that particular website. So how this hierarchy is based on, we will see in this slide. So hierarchy of name server, root name server. So it is the first server. So it is connected by a name server that cannot resolve the name. So this is the hierarchy. So this is the name server, this one, and this is the root server. This is the TLD, it is top level domain server, and this is the authoritative server. So we'll see how it goes. Okay, someone else. So what happens is it is contacted by a name server that cannot resolve the name. It contacts the authoritative server name, and if name mapping is not known, it then gets the mapping and returns the IP address to the host. Root server stores the root zone file, which contains information about top level domain servers like .com, .net, and .org. So what is happening is when you are trying to get an IP address, so first what happens is the name server. The name server is what it does. If you have visited the website in the past, it stores the IP addresses in the cache memory. Okay. And if it does not store the cache memory, the address is not available in the cache memory. What it does is it forwards it to the root name server. So what root name server does, it checks, okay, you want to access this csc.dtu.in. So what it does is it gives you an IP address of TLD, which is top level domain server. And what it does, it stores all the domain names like .edu, .in, which we have already discussed, right? So then what it does, it says, okay, you take this take this IP address of this particular domain, and now it gives you the IP address of this authoritative server. What authoritative server stores all the IP addresses, and then it gives the IP address to the name server, and the name server resolves the IP address and it gives to the host. So this is what is mentioned here. So top level domain server, it is responsible for .com, .org, which is TLD server, and all the top level country domains like UK, France, Canada, etc. They have information about authoritative domain server and know the name and IP address of each of the authoritative name server and the second level domains. Okay. Authoritative name servers are the organization's DNS servers providing authoritative host names to IP mapping for organization server. This is the server which stores the actual IP addresses. It can be maintained by the organization or service provider. In order to reach to csc.dtu.in, we have to ask the root domain DNS server. Then it will point out to the top level domain server and then to the authoritative domain server, which actually contains the IP address. So the authoritative domain server will return the associative IP address. Guys, any doubt on this slide?
No, sir.
Okay. So how does DNS work? So the working of DNS starts with converting a hostname into IP address. This we have already discussed. A domain name server as a distinctive identification for a website. It is used in place of an IP address to make it simpler for consumers to visit websites. Of course, domain name system works by executing the database, okay, whose work is to store the name of the host which are available on the internet. Okay. The top level domain server stores address information for top level domains such as .com, .net, .org, and so on. If a client sends the request, then the DNS resolver sends the request to DNS server. DNS resolver is something which is resolving your www.example.com to IP address, and then it sends a request to DNS servers to fetch the IP address. So DNS resolver resolves it to 192 point something something, and then it sends the request to DNS server to fetch that particular IP address which we are requesting. So in case when it does not contain that particular IP address with hostname, because DNS initially the DNS resolver, I've already told you that it stores IP address in its cache memory, and if it's not available, then it forwards the request to another DNS servers. When IP address has arrived to the resolver, it completes the request over internet protocols. Now we'll see, guys, any doubt on this slide? How we have, because we have already checked how it is working. So any doubt on this slide?
No, sir.
Okay. Now we'll move on. What is DNS lookup? So DNS lookup or DNS resolution can be simply termed as a process that helps in allowing devices and applications that translate readable domain names to corresponding IP addresses used by computer for communicating over the web. So it is self-explanatory. What are the steps in DNS lookup? So okay, often DNS lookup information is stored temporarily either on your own computer or within the DNS system itself. Okay, there are usually 8 steps involved in DNS lookup. If the information is already stored, some of these steps can be skipped, making the process faster. Here is an example of all the steps when the information is not cached. So a user types, suppose you're typing something like google.com into a browser. So the request goes to DNS resolver. So if the DNS resolver already has the cache memory, the other steps will not be followed. It will automatically redirect you to the google.com. But in this case, it is not cached. So what happens next is the resolver asks the root server where to find top level domain server for .com. So the resolver will ask this particular root name server that I need to go to this particular website. And then the website and it asks that I need to find .in here, but in here the example is .com. So that is stored in TLD server. The root server tells the resolver to contact .com TLD server. The resolver then asks the .com TLD server for IP address of example.com. The .com TLD server gives the resolver the IP address of domain's name server. The domain's name server mentioned here is the authoritative server. So what happens is when the request goes here, so it says that okay, it is a .com server. It may be on .in, .uk or anything. So if it is .com server, it gives its point to this authoritative server and says okay, this is a .com server, and now it's .in server, and now the total address is csc.dtu. So please fetch me the IP address of csc.dtu in domain. Okay. So it will find it. The resolver then asks the domain name server for IP address of example.com, and then the domain name server returns the IP address to the resolver. Guys, any doubt about this slide?
No, sir.
Okay, so moving on. So this is how it is working. So the host, this is a DNS resolver. If it has initially, the information is available, it directly sends. But if the information is not available, the IP address is not available in the cache memory, it sends to DNS root server. It checks that okay, what is the top level domain? If it is .in.cu, it says that okay, this is you need to go and check. It says the DNS resolver to go and check in the particular top level domain to the TLD domain server, and then it says okay, you are looking for this. I'm giving you the address of authoritative server where you can get all the information about where the information of that particular IP address is stored, and now it provides that information to DNS resolver, and then DNS resolver provides that IP address to the host, and the website is opened on the host. So we'll discuss what is DNS resolver. So our DNS resolver is simply called a DNS client and has a functionality of initiating the process of DNS lookup, which is also called DNS resolution. By using DNS resolver, application can easily access different websites and services present on the internet by using domain names that are very much friendly to the user, and that also resolves the problem of remembering IP address. Okay. It is also इसको DNS client भी बोलते हैं, and the functionality of for initiating the process. DNS लोगों को process को initiate करता है. Okay. By using DNS resolver, application can easily access. By using DNS resolver, you can easily access different website and services present on internet by using domain names. Domain names is your IP address, your address of the website. Okay. What is DNS caching? So DNS caching can be simply termed as a process. Caching is simply termed as a process used by DNS resolver for storing the previously resolved information on DNS that contains domain names and IP addresses for some time. Okay. The term is DNS caching, through which DNS resolver stores the IP addresses. The main principle of DNS caching is to speed up the process of future DNS lookup and also help in reducing the overall time to DNS resolution. Guys, any doubt on DNS caching and DNS resolver?
No, sir.
Okay. Now, what are the type of queries? So type of queries, there are three different type of queries. First one is recursive DNS queries, are those that takes place between recursive server and the client. Okay. The answer provided is either the full name resolution or error message saying that the domain name cannot be found. Recursive queries and either the answer or the error. Okay. Recursive queries क्या होता है? So this is an example of iterative query. Okay, recursive queries में क्या होगा? When host is asking for DNS resolver, it sends it to, if it's available, it provides. Otherwise, it sends to root DNS server. So rather root DNS server. So root DNS server will not send the IP address to DNS resolver. What it does is it will check that top level domain server and it directly forwarded that information to top level domain server, and top level domain server, if it checks the IP address and it then sends it to authoritative DNS server, and then it sends to DNS resolver. So that is recursive DNS query. And this is an example of iterative DNS queries where everything is being communicated through this DNS resolver, each and every process. So it takes place between recursive resolver, which is a local DNS server, and the non-local name servers like the root, TLD, and authoritative name servers. Iterative queries do not demand a name resolution. The name server may instead respond with a referral. Okay, so they are referring it that yeah, okay, this is the process is started. Now this is referring to him that take this IP address of DNS of top level domain server. Now top level domain server is telling DNS resolver that yes, please take IP address of this authoritative DNS server. So they are all referring to each other. Okay. The root server refers to the recursive server to the TLD, which refers it to the authoritative server. The authoritative server provides the domain name of the recursive server if it has it, and iterative queries resolve it, either an answer or a referral. Okay, any doubt about these two queries?
No, sir.
Okay. Non-recursive queries क्या होता है? Are those for which the recursive resolver already knows where to get answer. The answer is either cached or on the recursive server, or the recursive server knows to skip the root and TLD server and go directly to a specific authoritative server. It is non-recursive because there is no need, therefore no request for any more queries. So इसमें क्या होता है? If एक तो अगर information already available है तो it directly pass it to the client that yeah, this is the IP address, and because it is already cached, or recursive server or the recursive server exactly knows where the IP address is allocated, so it resolves it and give it to the host. If recursive resolver has cached IP address from a previous session and servers that address upon the next request, this is called a recursive query. Okay, so any doubt on this non-recursive queries?
No, sir.
Okay, so this was about all the information about DNS, and now we'll move to Telnet. So what is Telnet? So Telnet stands for teletype network. Okay, it is a client server application protocol that provides access to virtual terminal of remote system on a local area network or the internet. Okay, अभी मैं यहाँ बैठा हूँ, if I need to connect to any remote server, I can do it by using Telnet. Suppose I need to connect to some server in US. Okay, so I can connect that server by using Telnet if I have privileges to access that. If somebody has enabled my access to that particular computer using Telnet, I can connect to that server. The local computer uses Telnet client program, so I will use this client program, and my remote computer to which I had to connect will use Telnet server program. Okay, so Telnet is a type of protocol that enables one computer to connect to the local computer. It uses a standard TCP/IP protocol for virtual terminal services, which is provided by ISO. The computer which starts the connection is known as local computer. The computer which is being connected, that is, which accepts the connection, is known as remote computer. During Telnet operation, whatever is being performed on the remote computer will be displayed by local computer. Telnet operates on a client server principle. Any doubt on this first slide on Telnet?
No, sir.
Okay. Now we go about history of Telnet. So the Telnet protocol originates in late 1960s. It was created to provide remote terminal access and control over mainframes and mini computers. Initially, it was designed to be simple and secure method of connecting to a remote systems. This protocol allows users to access remote computers using a terminal or a command line interface. We always use command line interface or terminals. If we cannot Telnet using graphical user interface. Over time, Telnet use has diminished due to security concerns because it is not secure, and alternative like secure shell are now preferred for secure remote management. So login to Telnet, login process can be further categorized into two parts. First is local login and second one is remote login. So local login is when I'm logging in, like this is my terminal and my operating system, this is terminal driver, and then whatever application I need to access, I can access it by locally logging in. Second one is remote login. So remote login is a process in which user can log into a remote site, that is computer and user services that are available on a remote computer. With the help of a remote login, a user is able to understand the result of transferring the result of processing from remote computer to a local computer. So we will see how remote login works. So this is how remote login is working. So this is my local computer, and this is the application which I need to access on a different computer. So we'll learn in detail how it is happening. Okay. So the procedure of remote login is when a user types something on a local computer, the local operating system accepts the character. Like when you're typing something, like how you are connecting to Telnet, this is you're typing a command, then the local operating system accepts that character. So this is a local operating system. You're typing something, it is accepting that character. The local computer does not interpret the character and it will send to the Telnet client. So now it will send that information to Telnet client, whatever is being typed. Now Telnet client transforms this character into a universal character set called network virtual terminal. So what it does is whatever information is being typed, it sets into a form which is called network virtual terminal character, and it will pass them to local TCP/IP protocol. So it converts it into NVT, this client, and then it passes through TCP/IP to a network, and then it is received here. Now, commands or text which are not in form of NVT travel through the internet, and it will arrive at TCP/IP stack at remote computer. So my information arrived at remote computer here after traveling through TCP/IP through network. Now what happens is character are then delivered to the operating system and later on passed to the Telnet server. So whatever Telnet client has decoded that information, converted into NVT form, it goes here through the operating system and it goes to Telnet server. Now what Telnet server does is Telnet server changes those characters that can be understandable by remote computer. Okay. So it converts that NVT to a language which is understood by these remote computers. Okay. Now the remote operating system receives character from pseudo terminal driver, which is a piece of software that pretends that characters are coming from a terminal. So this thing, it is a software which is pretending that every information is coming from this terminal. Okay. Now the operating system then passes the character to the appropriate application program. Now what happens is, this operating system, what it does is, when when the telnet server converted the data from NVT to a computer understandable language, it goes to the pseudo terminal server, and then it goes to operating system, and operating system checks that, and whatever data you type for access the application, the operating system helps you to access that application on a remote computer. Okay, guys, any doubt about this remote login, how it is happening?
No, sir.
Okay, great. Now, what is network virtual terminal, which is where this telnet client is converting, and then telnet server is also converting. So NVT is a virtual terminal in a telnet that has a fundamental structure that is shared by many different type of real terminals. Okay, it has a fundamental structure that is shared by many different types of real terminals, and NVT was created to make communication viable between different type of terminals with different operating systems. Okay, so there are different operating systems like Windows, Mac, Linux. So what NVT does is, it is configured in a way that it takes information from any operating system and converts it into a language which any operating system can understand, whether it is local or whether it is remote. Now, how telnet works? So client server interaction. So the telnet client initiates the connection by sending request to telnet server. This is the client, and it initiates the request to connection request. It now the telnet client initiates the connection by sending request to the telnet server. Once the connection is established, the client can send commands to the server. Okay, the server processes these commands and responds accordingly. What is character flow? How is the character flow in this? So when the user types on a local computer, the local operating system accepts the character. This is the local operating system. It is accepting the character from whatever we are typing from here. Now the telnet client transforms those characters into a universal character set called NVT, which I've already discussed. Now this NVT character travel through the internet and remote computer via TCP/IP protocol. Whatever is typed is being converted, and then telnet client converted into NVT, and it is through TCP/IP and internet protocols. It is traveling from your local to your remote device. The remote telnet server converts this character into a format understandable by the remote computer. So this is what it is doing. This telnet server is converting that NVT into a language which is understood by computers. And then the remote operating system will receive the character from pseudo terminal server and passes them to appropriate application programs. Okay, now NVT is a virtual terminal server in Telnet that provides a common structure shared by different types of real terminals. Okay, it ensures communication compatibility between various terminals with different operating system. Any doubt on till now, guys?
No, sir.
Okay. So what are the uses of Telnet? Uses of Telnet are remote administration and management, network diagnostics, understanding command line interfaces, and automation and scripting, because it is working, you are directly working on command line, and you don't have any GUIs. What are the advantages of Telnet? The advantages, it provides remote access to someone's computer system. If you have privilege, you can access someone's remote computer system. You can access it, given you have been provided an access to that system. Telnet allows the user for more access with fewer problems in data transmission. Telnet saves a lot of time because it is very fast. The oldest system can be connected to a new system with Telnet having different operating system. It can work on different operating system. Even the old legacy servers and all can be connected through telnet. Now, disadvantages of telnet. What are the disadvantages? As it is somehow complex, it becomes difficult to beginners to understand. It is very complex because it is all command line where we have to write commands to perform each and every steps. Okay. Data is sent here in from plain text. That is why it is not secured. It is not at all secured. Some capabilities are disabled because of not proper interlinking of remote and local devices. There are capabilities which are disabled because of you mainly because of the command line interfaces, because we have to write a lot of codes, to perform anything on telnet. So this was about telnet. So what we do is we'll take a break and then we'll converge for another topic, which is SSH. Okay. So we'll meet by 10:15. Okay, guys.
Yes, sir.
Okay. Okay, guys, so let's start. Is my screen visible to you all?
Yes, sir.
Okay. So the next topic is SSH. So what is SSH? So SSH is, it is a secure shell or secure socket shell is a network protocol that gives user, particularly system administrators, a secure way to access a computer over an unsecured network. It is like Telnet, but it is secure. SSH also refers to a suite of utilities that implement the SSH protocol. Okay, Secure Shell provides strong password authentication and public key authentication. Okay, as well as encrypted data communication between two computers connecting over an open network, such as the internet. SSH is important for maintaining the security of systems, as the protocol acts as a secure way to provide access and management of network systems. So, what is saying that SSH provides strong password authentication and public key authentication, okay, as well as encrypted data communication between two computers connecting over an open network. It means connecting over an internet. So it is very secure, and then we'll see how it works in the later slides. So what are SSH keys? The secure shell is an access credential that is used in SSH protocol. In other words, it is a cryptographic network protocol, okay, that is used for transferring encrypted data over the network. The port number of SSH is 22, so it allows users to connect with server without having to remember or enter password for each systems. It always comes in key pairs. First is public key. Public key is that everyone can see it, no need to protect it. Private key stays in computer, must be protected. And now key pairs can be of following types: user key, host key, and session key. User key is if the public key and private key remains with the user, it is user key. If public key and private key are on remote system, it is host keys. And session key is used when large amount of data is to be transmitted from one system to another system. So any doubt about SSH keys, guys? Okay, I'm moving on. It's silent, so I guess no doubt. Now, secure shell is a protocol that allows you to connect securely to another computer over an unsecured network, that is internet. It was developed in 1995. SSH were designed to replace older models like Telnet, which transmitted data in plain text. So imagine a system administrator working from home who needs to manage a remote server at a company data center. Okay. So without SSH, they would have to worry about their login credentials being intercepted, leaving the server vulnerable to hackers. Suppose I have to log in, I'm a system administrator and I have to log into a remote server. So without SSH, if I can log in, but it is very easy for attackers or hackers to gain access. So instead of it, after using SSH, the administrator establishes a secure connection. So when I'm connecting through SSH, what I'm doing is I'm establishing a secure connection that encrypts all the data sent over internet. So what SSH is doing is encrypting all the data I'm sending over to internet. Okay. Now that they can now log in with their username and a private key, allowing them to safely execute commands. I would have a username and a private key, allowing me to safely execute command on the server, transfer files, and make necessary updates. All of these without the risk of spying eyes watching their action. Okay, I can do all these things with SSH and safely. The secure access is essential for maintaining the integrity of sensitive information of the company. Okay, Secure shell is an access credential that is used for in the SSH protocol. In other words, it is a cryptographic network protocol. Please remember that it is a cryptographic network protocol. Okay, that is used for transferring encrypted data over the internet. So it is a cryptographic network protocol which encrypts data before it transfer over internet. Any doubt on this slide? Okay, I'm moving on. So what are the features of SSH? First is encryption. Encrypted data is exchanged between the server and client, which ensures confidentiality and prevents unauthorized attacks to the system. Okay. Second is authentication. For authentication, SSH use public and private key pairs, which provide more security than traditional password authentication. Okay, we'll discuss about how the keys work in the next slides. Data integrity. SSH provides data integrity of the message exchange during communication. Tunneling. Through SSH, we can create secure tunnels for forwarding network connection over encrypted channels. So we can create a secure tunnel and forward connections, and that cannot be intercepted by hackers and all. SSH protocol. Now, to provide security between a client and a server, the SSH protocol is encryption. We have already seen this, that encryption is used in SSH protocol. All user authentication and file transfer are encrypted to protect network against attacks. So when SSH client is connected to SSH server, this is how the communication happens. First is as client initiate the connection by contacting servers. Then the server sends the public key, because public key is visible to all. Now, and then negotiate parameters to open secure channels. So it is doing the formality, and then user login to server host operating system the when the public key and the password and everything is filled, the user can log into the operating systems. Okay, so techniques using SSH. So first technique is symmetric cryptography. So what happens in this case? In symmetric key cryptography, the same key is used for encrypting and decrypting the message. A unique single key, shared key is kept between the sender and receiver. So this is for you examples, data encryption standard and advanced encryption standard. So what happens is, in this case, suppose I have to send a file to you guys. So what I'll do is, I'll encrypt the data with a key, and then I'll send the data. That you will receive the data, and then you have to open the data with the same key. So this is how it works, but this is not very efficient. So because the keys are same, and then the keys should be transferred to you by some methods. Okay, so suppose I'm transferring data and I'm transferring the key to you, and then someone has intercepted the key in between, so that would not be safe. Guys, you're understanding what I'm saying? Anybody? Yes, no? Am I audible? No answers. Asha, Momita, Kunal, Kumar,
Yes, sir.
am I
Yes, sir. You
audible?
are audible.
Then please
Yes, sir.
respond. No? You guys are not responding at all. Would I know? Okay. So any doubt on this slide? The
No, sir.
symmetric cryptography. Okay. Moving on to the next key. The next technique is asymmetric cryptography. So in this symmetric, we were using the same key to encrypt and decrypt. So in this case of asymmetric cryptography, what happens is, in asymmetric key cryptography, the key used for encrypting is different from the key used for decrypting the message. Okay, so we'll learn more about this. So how it is happening? So suppose I have to transfer data to you, any one of you. So I would have my public key and I would have my private key. And then in your case, you would have your public key and you would have your private key. Okay. And my public key can, if I am encrypting data with my public key, then my file could be open only with my private key. Okay. And if you are encrypting your data with your public key, you can decrypt it with your private key. So what happens in this case? Suppose I have to send data to you. So how would I do that? I would take your public key, because your public key is available to everyone. So I will encrypt data with your public key, and then I'll send it over to you, and then you would have your private key. So your private key would be able to open the data. You understand my point, what I'm trying to say here? Guys,
Yes. Yes, sir.
Yes,
okay.
sir.
So I'm repeating again, that in this case, what happens is there are two keys. One is public key, one is private key. Your public key, anyone can anyone can access your public key, but your private key is only with you. Similarly, you would have a public key and a private key, and any data which is encrypted with your public key could be opened by public key can be only opened by your private key. And so what, how could I send a message to you? So since your public key is available to me, is available to everyone, so I can encrypt data with your public key so that you would have your private key to decrypt that data. This is how it is. You understood my point? Any doubt on this?
Yes. No, sir.
Yes, sir.
Okay, fine. Then I'm moving on. So third technique is hashing. So hashing is what happens is hashing is a procedure using cryptography which converts variables length string to a fixed length string. This fixed length value is called hash value, which is generated by hash function. So this is very important. So what happens is there is a plain text. Now what happens, this hash function, this will convert this plain text to a variable length of string to a fixed length of string. Okay, it will convert this into a fixed length of strings, and then this fixed length of strings is called a hash value. Okay, this is a hash function. It converts this hash function into a string length which is called hash text. So we'll see how it happens. Suppose this is the website to check this. Yes, so this is a website where you can check. Suppose I am writing ABC and I convert this to a hash value. So yeah, so you can see this is SHA1, which is mentioned here is SHA2, this is the latest version. And then this is SHA256, it converts into 256 value of strings. So what happens in hashing is, suppose you have to store a data, you have a data, you convert this, your hash function will convert this data into this hash texts, and it stores in a database. Now, the one most important part of hashing is that once data is converted into this strings, it cannot be decrypted, or it is not converted back. So that is why hashing is mostly used in storing passwords. Suppose you are logging into Facebook with your user ID and password. So your password, your plain text password, the hash function is converting it into this hash text, and then it is stored in like this in a database. And then once you're logging in the hash text, when the server will query to the database, and if your hashed password is meeting with this hash text, only then you are able to access. Also, it is saved in hashed way, because even if the hacker has access to the database, the hackers will not be able to see your password because it is hashed, and the hashed data will not be converted back to its normal data. Guys, any doubt on this?
No, sir.
You understood what is hashing and how it happens and why it is important?
Yes, sir.
Okay, fine. SSH functions. So what are the functions of SSH? So there are multiple functions performed by SSH function. Here below are some functions. SSH provide high security as it encrypts all messages of communication between client and server. We have already seen. It provide confidentiality. Okay. SSH allow remote login, hence it is better alternative to telnet. SSH provide a secure file transfer protocol, which means we can transfer files over the internet securely. And then SSH supports tunneling, which provides more secure connection communication. Any doubt on SSH? So this is what I had for today, guys. If you have no doubt, then I'll close this call. So we have covered under application layer, we have covered these 4 topics. Last week we have covered application layer and DHCP, and this week we have covered these 3 topics: DNS, Telnet, and SSH. So any doubt on DNS, Telnet, SSH, guys, let me know. I would be sharing this slide once I have gone through all the topics under application layer. Okay.
Sir.
Yeah.
What's the difference between like Telnet and SSH? How do they differ from each other?
See, Telnet is sending data in the plain text only. Okay, it is not encrypting the data. So that is why it is not secure. So that is why we use SSH, because what it is doing is it is encrypting the data and it is authenticating. It needs authentication as well, authentication by the means of public key and private keys. But Telnet is simply anybody, if you can send the data and anybody can intercept it, because it is in plain text, it is not encrypted, and the information can be easily gathered by hackers. Okay.
And sir, like if a port is open while scanning, doing a reconnaissance, if any port is open, so let's say 443 port is open and it's running on Telnet. So can we just exploit that server?
Telnet has a different port altogether. It won't work with 443, right? Telnet is it's totally GUI. It's not a GUI based. It's a command line interface. So it cannot be mixed with that 443 port. So you cannot browse internet using Telnet. Telnet is a
Okay.
different port. Yeah, it is only used to connect to remote servers. That's it.
Okay, sir.
And SSH as well. These two are only used for connecting with a remote server, nothing else. Connecting, making changes to a remote server, updating the servers. That's all you can do from Telnet and SSH. Okay.
Yes, sir.
So to make Telnet more secure, SSH was discovered. Guys, any doubt?
No, sir.
Okay, then I have marked your attendance and then I'll be closing this call and then we'll meet next weekend. Okay. Thank you all. Happy weekend. Bye.
Thank you, sir.
Bye, sir. Thank you.
Thank you, sir.